In the dark, where the shadows play.
Testing 1, 2.
Hey, Myke, can you hear me?
Roger that. How you doing, Ben?
What's going on?
Not much. Doing a little live stream.
I can barely hear you.
Turn it down.
Is this music non-licensed?
How's that? Yeah, it's royalty free. Let me see here.
Can you hear me now?
Yeah.
Oh, okay, cool. All right, so I fixed my echo. Yeah, so I'm just doing a oh, dropped out. I'm just doing a few experiments. I wanted to hook up the coil to the speaker in a minute. What do you got going on in your end?
I'm going to go over a circuit here that I put together, I don't know, a while back.
Is it the dual or 3 transistor dual thief modification you were doing?
Should I turn the audio down a little more? Yeah. It's the toroidal double pole 2 coil setup. Let me see here. You got something you want to do?
So in the background, I am going to be setting up for my first experiment of the night. It's going to take me a few minutes, so go ahead and give us whatever you got, and I'll be working in the background, and I'll just let you know when I'm ready to present something.
All right. I'll be starting this in a little bit. Let me see here.
Yeah, I think I might have a quick smoke because I didn't get a chance to do that before the stream started, but let me... Oh, and grab some coffee. Let me grab some coffee too. But I do have a few experiments I wanted to do tonight as well, and some questions I had for you regarding your modified Joule Thief, but I'll leave those for later. Is this the video you had just uploaded? Is this the schematics for the system you for the video you just uploaded?
No. This is an old one, but if you want, I can go over the 2
The Joseph Newman, I think.
That one too, I can go over. Whatever one you want to do.
No, whatever you wanted to show. I wanted to see. You got so much going on. I'm trying to organize everything you have in my head.
Oh yeah. Everything I'm doing is double pole method.
So it's like a back EMF recovery.
All of them, yeah. All of them are recovering. The purpose of the double pole is to recover the back EMF to a single battery.
And it's from a single battery, you said?
Yeah, to recover it back to the source battery, right?
Gotcha.
So, like, there's no need for 2 batteries or swapping any batteries.
Right, yeah, just a single battery system, which is, keep it simple, I like.
Let me see here. I'm gonna move my camera.
So I'm always interested when you have systems that have 2 coils because, or a bifilar coil, because I can always try them with the vortex coil that I have.
Mm-hmm. My little camera here. Oh, by the way, this is the living room of the house. I got done with it. The walls,
nice.
And the lighting, fans, It
looks nice.
Yeah, this is brand new walls, and the structure and above the ceiling, the wood was replaced. I took videos of everything. I'll be updating.
Dude, that's a whole production studio right there and a lab.
Yeah, I'm getting this house ready for sale. It's the house I grew up in. Still a 1920s house. My dad's house. And, all right. So, let's see here. So let me take a snapshot of this circuit here. Which one do you want to do first? The 2 transistor Joule Thief? You want to go over that?
Yeah, let's start with. I mean, if you want to do that, we can start with.
I mean, whatever's a bit on your mind. I mean, I'll do that one if that's what you want to do.
I'm always thinking about the Joule Thief.
Yeah, Joule Thief's pretty cool.
I love the Joule Thief. It's one of my favorite circuits that I've been working with, and I've worked with a few different types of circuits, and I don't know, it just seems to like, it seems to work with these, you know, vortex coils quite easy. I just hooked up the fireball coil with 6 winds instead of 12, you know, thinking, oh shit, I might have to adjust the potentiometer resistance. No, it just snapped right into place and started exciting. So
I have to
circuit's
download
pretty
this.
good.
I can't believe I don't have it. It's over here. All right.
I know in one of your videos you were saying that one of the systems you're working with shows that we need a new exception to the right hand rule with your, you know, using your thumb to tell the orientation of the magnetic field.
Yeah, according to that rule, the North Pole is in the direction of where your thumb's pointing.
Mm-hmm. When your fingers are curled around.
And the winding is from the thumb in the direction of your finger, which would be counterclockwise.
Right.
Now, if you, right, counterclockwise. Your right hand is going to show, let me get this straight. Or clockwise, sorry, if you start with your pointy finger and go around the thumb, that would be counterclockwise.
Yeah, counterclockwise. So when
Is that
you're
right?
curling your, yeah, and then the thumb pointing up, that would be the supposed to be the North Pole, right?
Well, yeah, counterclockwise. It looks like counterclockwise. Your hand shows, your right hand shows counterclockwise wound. If you start with either the thumb or the pointy finger, it's still going to be counterclockwise. So that's the direction of the north field, is with the direction your thumb is pointing.
Right.
But they don't, I don't know on the right hand rule where the plus and the minus goes on those two ends of the coil, which makes a difference, because when you flip those plus and minus, the north field goes to the other side. So, you know, that's all I'm saying. The rule's a little bit vague.
Well, there's always
you can
room
look it
in
up,
science for additional information that I think
probably missing, right?
Yeah, there's all these gaps I think that we need to fill, and it's just unfortunate that the standard traditional mainstream channels that we have to, you know, like the peer review system that we have, we're kind of locked out of that. If we go against any kind of established theory or threaten any kind of, you know, academic hierarchy.
I found a nice image of the rule. There it is. I'll bring that up. There it is. Direction of force.
Fleming's right-hand rule. Okay. Interesting.
The magnetic field is, you know, pushing away from the surface of the coil, not the two ends, but the actual surface.
I've not seen this diagram before. This is interesting.
Direction of current is, yeah, okay, yeah. So the plus is where your middle finger is, and the minus is the thumb, and that would make the thumb pointing the north field, which is correct if you put the plus in that point of the coil and the minus at the other end of the coil where the thumb is. You would have a north field there. But if you flip those polarities on that same counterclockwise wound coil that you see on the hand there, you would get that is counterclockwise, right? Yeah. You would get
it
a
really
count
depends
there.
on which way you're looking at it, but yeah,
It's a
from this point of
counterclockwise.
view, it is.
Well, I'm saying if you put the plus where the thumb is and the minus where the middle finger is, the thumb would be a south instead of a north, and the direction of current would not. Why do they have two arrows on the direction of current? They're just trying to make things difficult. You see what I'm saying, right?
Yeah, this is new to me. I have to take a minute to absorb this because
And current cannot go in two directions. It's either, well, I guess it can. Yeah.
it's
whatever.
meant to simplify it, but it's just making me have more questions.
How many? You wanted me to remove one of you here? You got two, or you got another camera?
No, keep both, because one of them allows me to use my microphone without it echoing. I don't know. It's just a weird setup I have to do. I'm gonna put my camera back on in a minute when I get set up with the experiment.
Let me download this. I'm done thinking about the right-hand rule. It's just, it's enough. I got enough out of it to understand the basics.
Right, but the point is, you found something, an anomaly or whatever in your system that kind of requires an adjustment to the rule.
Maybe I'm understanding it different than others. I don't know.
Yeah, it's possible. I mean, you know, like we have to consider everything, but at the same time, you know, it is a possibility that, you know, there could be an exception, you know.
All right, so there you go. Let's load that. Maybe I'll do a share screen instead. So that'd be in, is this it? There it is, 24, okay. Let me open that with Photo Editor. I use a Photo Editor to do all the stuff I do in the videos and stuff. All right. So that's the double pole switching Jewel Thief. Let me see here. Do I need that? No. All right, so yeah, let me switch over to so what did you want to go over here? Don't need that.
So let's just take a look at the circuit, and I know you got a couple of modifications to it. Let's just go over the modifications and what they accomplish over the, you know, the standard circuit. So for instance, you got the second transistor in there. Like what's the point of having the second transistor? Is that to like kind of produce like a more oscillating waveform?
No, for double pole switching. So
double pole switching. Okay. So could you describe what that means though?
It means switching the plus and the minus of the source. basically connecting to the plus and the minus at the same time.
The potential. Okay, the over the source. Okay.
And disconnecting from the plus and minus at the same time.
So it's switching the polarity of the source battery.
No. Not this one. This one is not switching the polarity. It's just connecting and disconnecting. So this transistor here will close, and this one will close, thereby connecting these two ends of the battery to this coil. Okay.
So I'm trying to understand. Does that mean like the second transistor, it basically utilizes the one coil while the other coil is off?
The coil to the left is just a trigger coil for creating your signal, your switching signal, your on and off pulse. And the coil on the right is the actual energized coil that delivers power.
And that's the one that's being switched on and off.
Right. The coil on the left is just for your signal generator. So you see the green line, how it connects from plus all the way around through the coil to minus, following the arrows on the load right here, the arrow. That's the direction of the current. The arrow, the diode. Current's going that way, from plus to minus. And through the coil back to minus. Okay, so what's going on here is I'm switching the plus and I'm connecting and disconnecting from the plus and the minus of the source battery. Connecting what and disconnecting what? This drive coil, this coil here. Okay. So when the switches are open, right now they're open, there's no power going anywhere because there's no path from the battery to the coil. So nothing's happening here. Except flyback, assuming you energized the coil previous to this cycle of open cycle.
But in terms of the energy that's coming out of the battery, there's nothing on that phase.
Can you see the circuit?
Yes.
Why is it not showing on the screen here? So, you want me to go over that again?
No, but I want to Oh, I see it. Okay, yeah, I was gonna ask you, that was my next question. Is one of those a PNP instead of an NPN? And yes, the top one looks like it's a PNP, and then the bottom is an NPN.
Right. So what goes on with this is I was trying to find a way to switch with transistors to Joule Thief. And I realized I needed a PNP and an NPN to do it, to be able to switch with one trigger coil. So what happens with a PNP is the plus goes in the emitter through this diode, out the base. And this plus has to meet the negative through this coil and through this resistor. And to get to the negative, it hits the base of the NPN and out the emitter.
So you basically got the base of a transistor on either end of the coil.
Well, no. What was that? Say that again.
You basically have the base of a transistor on either end of the coil. You got the PNP on one end and then the end. Yeah.
Correct. But to get this positive to flow through both transistors, you have to use a PNP and an NPN.
Right.
The positive has to go in the PNP, out the PNP.
Yeah, because you have to create that potential difference. It's not going to want to seek out
this
higher potential, lower potential is what's seeking out.
The battery's positive is going to channel through this coil and resistor.
Yeah.
To the base of the NPN.
And that's the 1K resistor you got?
Out the emitter to the negative. And once it hits the negative, both of these transistors will be triggered at the same time. And they will close.
What's the resistance in the coil you're working with here in the
1K.
schematic? You know, 1K. Okay.
So now that they're both closed, thanks to the battery biasing the plus from the battery through the PNP's emitter, out the PNP's base, through the coil and the resistor to the NPN space, and out the NPN's emitter to the negative. That biasing triggers both these coils to close. And what happens is, when they close, now plus energy can channel through the PNP, through the drive coil, out the load, back to the negative through the NPN, and charge the drive coil. Now it gets charged. Once it gets charged, the circuit opens up. Why does the circuit open up? Here's what I think. Because this is, one is clockwise wound and the other is counterclockwise. The fields are opposing. And so when this coil, the drive coil, gets energized, it cancels the field on this coil. By canceling the field on the trigger winding, you turn off the transistors. Turns it off. In other words, it opens them up, so there's no connection from the source to the drive coil anymore.
Right.
And that turns off the drive coil, creating your pulse. Once the drive coil is off, the flyback happens. And here's how the flyback goes. So you know that you put the plus from the source to this side of the coil, and the minus is on the other side of the drive coil during your forward charge cycle. Once the flyback happens and the polarity of the drive coil reverses, and now this becomes a negative and this becomes a positive, and the flyback will channel through the load again, just like the forward power channeled through the load. The flyback will channel through the load also. And whatever the load, remember, this is open, so there's no path here. Whatever the load didn't take in flyback will go back to the battery through this high voltage diode into the plus terminal of the battery. That's plus flyback. Through the battery, out the negative through this diode. That's plus potential channeling through that negative, through that diode, over to the other side of the coil, meeting the negative of the flyback. And that's how the flyback, channels through the source battery and the load. So I think that's pretty efficient. So whatever the load doesn't use, the battery will capture. I think that's awesome. Yeah,
that's an awesome design.
I'm definitely, if I'm going to build another Joule Thief, I built one for emergency. It works. But
that's what they were designed for too. I found out is they were designed as an emergency circuit.
Yeah, it worked. I had a hurricane, the power was off. I used it. I had light every night for a couple of weeks on one battery. Like about six. I think it was 5 amp or 7 amp batteries that I put in, I think series or parallel. I don't know. And they were lead alum batteries too, and they lasted. That light ran for a couple of weeks till the power. It still had charge before the power came back on. But if you do the Joule Thief this way, it'll last even longer because all the. Oh, let me bring up the other Joule Thief circuit, the standard one. I'll show you the difference. Don't tell me I don't have this image. I guess I don't. So Let me find it. Standard Joule Thief.
Right. I am almost set up to do my first test. Give me a second.
There it is. So let me open that one. All right, that's the standard Joule Thief. Now, I'll show you that on this one. Let me see here. Yeah, so you there, Ben?
Yes.
So here you see the standard Joule Thief, right? Here's the difference. You ready? You ready? Ben?
Yep.
Are you paying attention? Let me show you the difference between this standard Joule Thief and the other modified one with double pole. The difference is the plus, again, it primes the trigger winding through the resistor and the coil, through the base of the transistor, out the emitter to the negative of the battery, thereby switching the transistor to close by doing that. And then the transistor closes, and the plus from the same battery goes through the drive coil and charges up, right? And when it does that, it turns off the trigger winding because the windings are opposite to each other. So one should cancel the other. And when it turns off the trigger winding, the drive coil is done charging. Now the switch opens, you know, and the drive coil flies back in reverse polarity. Now, the difference is this, of course, this plus is there and then minus there on your standard charge cycle. And then the polarity flips, and this becomes a negative and that becomes a positive. And the load can take the positive flyback. Did I get disconnected just now? Can you hear me?
Yes, I can hear you. I got my mic muted.
All right, so what I was saying is the flyback can now channel through this load, through the bias of the load diode, LED, and to the negative, right? So the positive flyback goes through the load, through the battery to the negative side of the flyback to complete the cycle. The difference is, I'm going to draw in red the flyback polarity hitting this battery, okay? That's the flyback polarity hitting the battery. And in green is the actual polarity of the battery. So that's your plus of the battery right there. So the flyback cannot charge the battery like that. The polarity is the wrong direction. You see? Is that Ben? Yeah, I'm talking to myself here. Ben Shapiro. Ben. Did you see that?
Hello?
Yeah. Did you catch that?
Say it again.
All right. The difference between the double pole configuration on the Joule Thief and the standard is that when the polarity of this coil flips from plus and minus to minus and plus, as you see now, that's the flyback polarity, and it can now channel through the load, and it can use the battery as a path to get to negative, and thereby the load will use the flyback power to operate. Your light will run off the flyback. The problem is the flyback polarity is in red and the battery polarity is in green. Do you see the difference?
Yes.
Okay, what's the problem here? The polarity is opposite, right?
Yeah, the polarity is opposite.
Right, so the battery is not going to charge. Not off the flyback anyway. It will allow the flyback to pass through it to run the load, but it's not going to charge. You see what I'm saying? For this battery to charge off the flyback has to be negative here and positive here. But it's not. It's positive here and negative here. That doesn't mean that the flyback cannot go through the battery to meet the negative.
Right. You might get some interesting effects if the battery is like fully conditioned with negative electricity. Who knows, you know?
Right. But you're missing the point here. This is the modified circuit, okay? Where the flyback is plus here and negative here. Flyback can again go through the load like the standard Joule Thief. Okay, and instead of having to go through the battery in the wrong polarity, it can go through the battery in the correct polarity. Thereby, the battery now can charge. Okay.
Right. You solved the problem.
Yeah, I think so. I don't know if it wasn't a
Well, have
problem.
you run it in a simulator yet?
No, it wasn't a problem before. The Joule Thief would still run off the flyback. Only difference is the source battery would only act like a channel for the flyback, but it wouldn't charge off of it.
It wouldn't charge it, yeah.
Because the polarity.
I mean, to me, that's an issue that should be overcome.
That nobody noticed.
Recycling energy, so.
I didn't notice it either until I did this modification. So.
Interesting.
I wasn't looking for it. I was just trying to modify the flyback to double pole switch because I knew I could channel the flyback back to the battery.
So in certain original configurations, the Joule Thief could, partially delay the dipole from collapsing, but this method will actually restore it by injecting additional energy into the battery.
Right. The battery will receive flyback energy in the correct polarity. The same way it happens in the Bedini circuit.
Interesting.
The Bedini circuit does not send flyback to the charge battery in reverse polarity. It's correctly polarized to the battery. So the flyback positive hits the positive of the battery, and the flyback negative hits the negative of the battery in the Bedini circuit, the charge battery. So
I'm going to take a quick break. I'm going to go and have a quick smoke. When I come back, I do have something ready. I tried to test the speaker, and the coil is just not powerful enough with 6 winds per channel. I don't think it didn't produce any effect for the giant magnet I have. I'm going to have to, maybe jerry rig my own, speaker that's a little bit more sensitive. But we do have the coil working, and I'm going to move on to the next experiment. We'll try
Let
the
me know when
magnetic
you're ready.
levitation. Yeah, we'll try the magnetic levitation when I come back. You know, I was talking about that before, the idea of using 2 frequencies, and one of them's 90 degrees phase shifted. So I'm kind of excited to try that. Hopefully we can get the fucking magnet to levitate, but
All right.
But yeah, I'll be right back.
Okay. That's right. Okay.
Это все лишь миг судьбы. Я недоволен, все так серьезно. Терпение грань взрывает мир. И здесь, увы, недоосторожно. Пространство швы, мечта рассыпалась в осколки. Крик рвал крылья любви, падали перьями мои мечты.
Okay. Here we have the toroidal double pole switching 2 coil setup. And how does this one work? It works by double pole switching. I'll go over this. So you have your plus on the battery here and your minus. What happens is, let's start with the top coil. This switch up here will close together with this switch. So 2 switches, double pole. Okay, both those switches will close, enabling the plus from the battery to go through to charge up the coil, like so. And the coil gets charged to negative. And then what happens here is you have your north on this side and your south on this side. All right, so we see how the coil got charged when the 2 switches closed. And because your plus is here and your minus is here, and this is a counterclockwise wound coil, that means the north is on this side. If it were clockwise, the north would be on the other side. But it's not clockwise, it's counterclockwise. So the north is on this side. I had to use, both of these coils are counterclockwise. They had to be counterclockwise for this to work. Excuse me. There was no way to do it with clockwise wound coils. And to work in what way? Well, the goal was to, when the top coil is charged, the goal was to send the charge through the core to the other coil. Of course, while it's doing that, you know, whatever rotor you have in the center here with a magnet can spin. But when the top coil is charged with the north on the right and the south on the left, what was that noise? Your browser has lost connection to your camera. Okay, whatever. Screw the camera. So the north is on the right, south is on the left. Now the bottom coil is inactive. It's not being switched when the top coil is active. So the bottom coil can be a stator coil or a pickup coil, pick up the charge. And it's going to pick up the charge from the north on the right. It's going to send this north this way through the coil, I guess that way. And that would be the rotation of the field. And so that basically means the north from the top coil lands down there and the south is over here. And because the north is on the bottom coil on the right side, the bottom coil receives that north and channels it this way into the source battery's positive, out the negative to the south of the coil, same coil. You see that? Okay, so that's how the top coil can induce the bottom coil and send that induction back to the source battery. So whatever the rotor doesn't use to spin in the center, the bottom coil being inactive during that pulse on the top coil can be a pickup coil for whatever the rotor doesn't use. And it will send that leftover power back to the battery. Okay, so that's the top coil cycle. All right, now the top coil is no longer induced and it's opening up the circuit. And these two switches now are open. Okay. And then the bottom coil gets switched. So these two bottom switches close. And when they close, the plus energy comes out the battery right here through the coil, out the other end of the coil to negative of the battery, thereby charging the bottom coil. And you see plus went in the coil on the left side and counterclockwise. So that makes the north where it is here on the left and the south on the right. So what happens now is the north field from the bottom coil being induced will channel up through the core in this direction and out this side to meet the south, thereby putting a north on this side of the coil and a south on this side of the coil. The top coil now. The top coil is inactive, whereas before it was active. Now it's inactive, but the bottom coil is active. And its induction is channeling to the top coil. And because on the left side of the top coil you have a north, that enables the stator coil on the top to now, it's a stator coil now. And switches are open, but there's still a channel here for the power to come out the north of the north field of that coil on the top coil can come out through that diode and hit the positive of the battery, go through the positive, out the negative, and all the way over to here through this diode on the right side and meet the south side of the coil, thereby charging the battery. So basically whatever energy came out the battery and went into the bottom coil goes into the top coil back into the battery. But in that process of going from the bottom coil to the top, if you have a shaft here with a magnet in the center of this core, you know, it will spin. It will spin. And as it spins, so will the power go from the bottom coil to the top coil and back into the battery. I think that's pretty efficient. So that's basically the concept of this whole system. The toroidal now, you know, it's a bifilar, but it doesn't operate like your standard bifilar. You don't have, it's not a bifilar because the coils are not wound around each other. You have one coil wound on one side of the toroid and the other coil wound on the other side of the toroid. They're both counterclockwise wound and they're both double pole switched, and you have your diodes in the position you see here. To verify that when this bottom coil is being switched and the plus comes out here through the coil back to negative, this direction here is blocked by the diode. Yeah. But that diode serves a function of sending power back to the battery in a different part of the cycle. Yeah. So yeah, we went over that. May have to rewind this and watch it again. But I just wanted to go over this real quick. We'll wait for Ben to get his presentation ready.
Yeah, it's not really a presentation. I've been trying to get this sphere to levitate inside the coil and stabilize. So we're just trying a couple of new methods. I've been silently testing a couple of things in the background. The speaker is not going to work tonight. I don't have enough power for this coil in order to shake this giant magnet. Although I do have a powerful enough driver, the stereo amp is well powerful enough. So we're going to try to get that sphere to levitate. I do have a couple of ideas. The only limitation I have with the software I'm using is that it's going to be hard for me to sweep the frequency using dual mode. And that's something that I just recently discovered. Like I can phase shift the second frequency to 90 degrees and have a base frequency and then mess with those. But to spin the sphere, you really need to kind of be able to sweep the frequency to, you know, get it to gain a little momentum. So I'm just going to play around with that. I'm going to see if I can get it going.
You have a circuit?
So, yes, actually, let me pull that up for you because I do have a circuit to share that we can look at while I'm doing this. So, actually, that's a good idea because I forgot to read this to you guys. Can you see this?
Hold on.
All right, so here's the standard I call the Nunez method. That's the open and closed circuit method for coil excitation using vortex coils. We're not using that method tonight. This diagram, at least the closed circuit method on the left-hand side, it produces a strong pseudo monopole for driving a magnetic rotary. You know, we pick up a strong monopole. However, this is not the only method for driving a magnetic rotary with the coil. And that's something I recently discovered. We have other configurations to play around with that were not well documented, or nothing is left online for us to kind of deconstruct or reverse engineer. So we're kind of aiming in the dark here in terms of how to levitate the sphere. But instead of the monopole method that we use, the Nunez method, I call it, we can use what I call the dual channel method. And this method is simply disconnecting channel A from channel B. If you look at the diagram, let me see if I can, it's hard for me. Let me shrink it a little bit. That way you can get a full picture. All right, so let's shrink it a little bit more.
Just like the Joule Thief, the coils are opposing.
Yes, so, but yeah, it's a bifilar coil, and you can see the two channels for the coil split off, and the end of channel A is actually connected to the beginning of channel B in this monopole speaker method. So this actually constrains our system quite a bit regarding producing a strong electromagnetic field. From my experience, this method kind of condenses the magnetic field in the center of the coil and increases the resistance and impedance of your coil, making it exponentially harder to produce a strong electromagnetic field outside of the core of the coil, which is the center. So I think it is my theory, but that by disconnecting these two and using them as separate channels in the stereo amp, each coil acting as a speaker, essentially, the dual channel method should be able to produce a stronger field that extends outside of the coil's physical frame into the surrounding environment, whereas this method seems to condense it in the center, and it compresses the north pole, so it's kind of negligible, and you just get a big south pole, a monopole. So that's what we're doing, and I do have a schematic for that. I gotta shrink this down so you guys can see the full thing. It's a very, very simple system. You have basically your stereo amp on the top, and that's also what you would use to input your frequency, like put your phone into the input, or a laptop, or whatever you use for your frequency generator. And then each channel from the stereo amp goes to its own coil. So you see channel A has its own positive and negative, and channel B has its own positive and negative output from the amp. The only difference is we flip them. So the start of channel A is hooked up to the positive of the stereo amp, and the end of channel B is hooked up to the positive of channel B. This
looks like the
right.
Even,
So this,
even though there are opposing lines on those coils, because of the way the polarity is, the north and will match the north on the other coil. So they won't
say that
oppose.
again, Mike.
Well, I mean, if you look at the polarity on the connection of those coils, you have the left coil, the plus is on the top and the minus is on the bottom, and the right coil, the plus is on the bottom. But those two coils are, opposite wound, which means.
So you think I should switch the polarity of the second one?
No. Is that how the schematic came? Then leave it.
No, this is all new. This is my idea. Like I'm still testing this. This
okay,
is not been validated at all. We're testing this now, so it could be wrong. I might have to switch the positive and negative on the second channel. If you think that that's something we can try, we can definitely do.
Are those two coils
it'd be worth it.
Is one of those coils a trigger for creating your signal?
So essentially,
no,
there is no trigger. It's basically each coil acting as a load for the stereo amp.
Right.
So each channel is, each coil is acting as basically its own speaker.
Well, the way you have the coils counterclockwise and clockwise, and the polarity how they're connected, the left coil, the north field, would be at the bottom. Wait, is that counterclockwise? Yeah. So the left coil, the north, would be at the top, and the right coil, the north, would be at the top.
So to get it to, so the idea here is to get it counter-rotational. So
well, hold on. The poles of these two coils will be alike. They'll be the alike coils. The alike poles will be meeting each other. So the north will meet the north, which would repel, push away. If you want them to pull together, you need the opposite pole of the north meeting the south. So look,
we can try it both ways.
Let me explain something. The left coil. Look at the left coil. The plus is going into the top. The left coil is a counterclockwise. The right coil is clockwise. So since the plus starts at the top of the left coil and exits the bottom, being a counterclockwise coil, the north would still be at the top. But if it was a clockwise coil, the north would be at the bottom. But it's not.
No, you're right. These are different winds.
And
so
the way
essentially,
what I'm just saying is the way it's set up and the way you got your poles connected, your plus and minus, the north is at the top at both of those coils, and the south is at the bottom, which means there will be a repulsion effect. The two coils.
Right, that's exactly what I'm asking you. You think I should switch them because they need to be counter-rotational?
I don't know. I mean, it's an experiment. Like, repulsion could produce.
Well, I tested it this way. I didn't really get any interesting effects, so I'm wondering if I should switch them because they are different directions. The one is clockwise and the other one is counterclockwise. So that would make sense.
The coil itself, you just switch the polarity on the coil.
Interesting. Let me switch that on the stereo amp real quick because I have a feeling
switch the polarity
the
on just
schematic
one of the
might need to be adjusted.
Either or, it doesn't matter which one. If you switch the polarity on either or.
But no, that makes sense. I do have a feeling that this might be the opposite way for the second channel, just because it is in a different direction.
Let me see that. Those arrows, the right arrows in the right circle. Which way are they pointing outward? To the right? Yeah. It's okay. From that diagram of the field diagram, it looks like repulsion because the arrows are pushing away from each other. So that's how you got it hooked up. That's how it's wired in repulsive.
So okay. Well, I'm gonna do some testing either way. I'm not gonna change it just right away because I do have a couple more ideas to see if we can get this thing to levitate. But it is good to keep in mind that this might not be the proper configuration. There's a lot of different ways you can hook up this coil apparently to the stereo amp, and maybe we might even need 3 channels. Who knows?
Well, look at
the idea.
The field diagram at the bottom, the 2 circles and the arrows. You see how the arrows are pushing away from each other?
Mm-hmm.
That's repulsion. And according to the way it's wired up, it's correct.
Right.
Because you have
the idea of using 2 different frequencies.
The 2 norths of the 2 coils are meeting each other. That would repel. Which is what the diagram shows, repulsion.
So we also need 2 different frequencies, and one of them phase shifted 90 degrees.
It doesn't matter what frequencies you use, they're still going to repel. You're still going to have a north at the top and on the left, and a north at the top on the right.
No, I'm just describing the setup. That's what we're doing. We're using 2 different frequencies, and then we're adjusting one by 90 degrees to kind of produce like hopefully a 3 kicks in a row kind of deal, where it rotates 90 degrees and gives it a little bump.
Yeah, I guess if you're repelling, if you time it, you could have a more effective repulsion.
So like the main issue that I thought I had was power and the power factor, but it turns out like I have way more than enough power to levitate this thing, and it just won't stabilize. There's something else going on, so we need to figure out what's missing here, and I think it has something to do with multiple frequencies.
What I'm saying is, if you have the 2 frequencies matching in phase, it'd be like let me put my camera on. It'd be like this, same time. But if you switch one frequency a little bit off, you'd be like this. But right, if they're in sync, this is what you're going to get: repel, 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 repel. But if they're a little bit off sync, you're going to get, which could cause a more effective rotation, is what I'm saying.
Like an asymmetric effect could stabilize it a little bit more. Saying? Interesting.
If you have it like this,
I mean,
the repulsion is going to be like that.
I just don't know, like
the repulsion is going to be like that. It's going to be like the.
I set the base frequency to 432, and I don't think we can get that high though.
But you see what I'm saying, though. That's what happens when you change the frequency on one coil if they're not matching the 2 frequencies. If they're matching,
that's why I'm thinking the base frequency
on each coil.
The base frequency is
an unmatched frequency on each coil. Depends what you want on the rotation.
I need a lower one than 432, though.
Well, you don't want to go too far apart on the 2 frequencies, because if one frequency is a slow frequency and the other one's a fast frequency, this is hard to do. You see what I'm saying?
Yeah, I think the base frequency has to be the same as the other frequency. I'm not sure, honestly.
Well, 432 and 4032 is a huge difference in rotational speed. It's 10 times difference. So for every 10 turns, you'll have 1 turn on the other. One side will turn 10 times, the other side will turn once.
I think I'm going to hook it up to the power supply so we can test it for longer periods of time, because I have it hooked up to the battery right now, and the battery is not doing.
Try 10 to 1, or like 10 to 1 is a good ratio, or 1 to 5, or 1 to 3. 1 to 3. What would that be? That would be a harmonic. A third. And a fifth. See, I would go 3, 5, and maybe 9.
So yeah, harmonics are going to be important. I've been keeping track of the frequencies for at least the monopole method. There are like certain frequencies the sphere spins really well. Like we get the monopole real clear. and that's like 40 hertz, 120 hertz, 270 hertz. But
Right,
I
that's
didn't get
1 to 3.
anything like
40 and
clear
120.
above 270. It just disappears after that.
So 40 and 120 is 1 to 3. That's a harmonic. So 40 is your bass and 120 is your harmonic. But I wouldn't use 40.
Yeah.
I wouldn't use 40. I'd use 45. Because
45
is that's a vortex number. 4 and 5 is 9. So you multiply 45 times 3, and that's 135. Yeah. So yeah.
So aim for 135.
135.
Hertz.
Confirmed. 100. What's 1 plus 3 and 5?
So this is for the other
9.
coil,
It's
but
9.
yeah, we'll test it on this coil too, obviously. But if it doesn't work, these are
Try
numbers for the other
45
coils. So
and
let's-
135.
Hold on, let me write that down. You said what?
45 hertz and 135 hertz. Keep it in the vortex and field numbers, because 45 is a 9 number, and 135.
You said say those numbers again.
45 is a 9 number. It's 4 plus 5 is 9. 135 is a 9 number. 1 plus 3 is 4. Plus
That's
5
true.
is 9.
And then
Those ratios are in the vortex range, the vortex math.
yeah, I don't think I want to go too much higher than that, but yeah, that's a good. Okay, so aim for 135.
And if you're not going to do 135, do a fifth. So whatever 45 times 5 is, that would be a fifth. That would be another harmonic. A third and a fifth is like in music.
Interesting. I really want to get this sphere
That
to
would be
levitate and synchronize.
That 40 hertz is not a vortex number, so it won't be creating the cymatic vibration like you would get with 45. So what's 45 times 5? That's 225. So 45 and 225 would be a fifth. A fifth. And 2 plus 2 is 4, plus 5 is 9. Again, another 9. What if you did 45 times 9? That's 405. Another 9 number. 4 plus 0 plus 5. Or 18, or even 15. 45 times 15, 1 and 5 is 6. So 45 times 15. 675. 6 plus 7 is 13. Plus 5 is 18. 1 and 8 is 9. That's how you know when you're in the resonant. Those are resonant frequencies, okay? If you add the digits and you get a 3, 6, or 9, that would be a resonant frequency. That's how you can tell if the frequency is a resonant frequency. So like 1028, 1 plus 0 plus 2 is 3. Yeah, 8 is 11. 528, 5 plus 2 is 7, plus 8 is 15. 1 and 5 is 6. That's why 528 is one of the resonant frequencies. There's a lot of those numbers, resonant numbers, to pick from. But you're right, maybe a low frequency and a high frequency. You're trying to get the sphere to levitate inside the center of the coil, the toroid.
Yeah, so there's a video I can bring up in a minute, but yes, we're trying to get it to levitate and synchronize too, where we can actually take it out. You know, you've seen the videos. I think Jack Scholes had one on him synchronizing the sphere, where he took it outside the coil like 20 feet. You know, he turned off the system and it kind of got a little faster and continued to spin.
This tune is so goth.
So we might have to actually, I'm going to switch to the other coil because this one is not producing any kind of magnetic rotation without the phase angle adjusted, which is interesting. I'm wondering if it has something to do with it's only got 6 winds per channel instead of the other coil, which has 11. So I think maybe it's just not enough magnetic flux density in the, the coil for the size of it. I don't know, because it's a big coil. So I'm going to switch to the other coil because it's the more efficient one that we've been working with. So
what's the gauges on that other one?
Is it 23 or 24 for both of them? But I do have a smaller one that's like 28 gauge that I'm almost finished putting it together. I can actually show it to you.
Well, how many watts does your amp have?
1,000 watts.
Oh, then that 26 gauge just, it can handle that, yeah.
Yeah, the only limitation is my power supply, which is 10 amps, and I don't know if I want to push it.
You know what
you
can do is, you know how the speaker's output on your amp has an ohms on it?
Yes, yes.
It's like 2 ohms or 4 ohms or 6 ohms. It's somewhere around there.
I don't know if mine has it, but yeah, usually they do, right?
What I'm saying is, whatever the ohms output is on your speaker on the stereo, make your coil have the same amount of ohms.
Right, to match the resistance and impedance. Okay.
You can add a resistor to the coil.
I'm not really sure because it doesn't have it written on there. I have to look at the manual.
It's on
Maybe
the back
it has
of
in the
the amp.
manual.
It should say it should say right on the back of the amp where the speaker outputs are.
Sure.
You need a magnifying glass to see that, though. I mean, I would. I can't see. I'm farsighted.
Yeah, it's gotta be. No, I'm not gonna. All the wiring is very delicate. I'm not gonna flip it right now. I'm gonna.
No, you don't do it now. But when you got time, consider
I got
that.
the manual right here.
Yeah. So whatever the ohms is on that amp output per channel, each channel has rated for.
Oh, it says minimum working impedance is 2 ohms stereo or 4 ohms mono.
So you're going stereo, so might as well go with 2 ohms. And your coil probably has more than 2 ohms. So
yeah. Especially when you connect the 2 coils together, it increases the resistance quite a bit. So, but disconnecting them, you're measuring them separately. So,
what I'm saying is, if you lower the resistance on your coil, you could take more power from the amp. So let's say your coil has 10 ohms. If you lower that to closer to 2, you get the full watts. You can get all the watts out of that amp into the.
And how
coil.
would I do that? Could I put like a?
You gotta make another coil with less windings, less turns, same gauge.
I mean, I have one.
Or a thicker gauge, same amount of turns. Like go from 26 to 22, or.
So. This is a smaller gauge.
I'm
I'm not sure if that's gonna have the same effect, but this is a smaller coil that we've been working on.
Yeah, find something closer to 2 ohms or lower resistance. That way it could take more power out of the amp. And that would get you closer to being able to levitate that ball. You needed to get the power to do that. you got to consider that that sphere has weight, and it takes energy to lift that weight.
Peccatoribus, nunc et in hora mortis nostrae. Ave Maria, Deus. Ave Maria.
Come on. Do it. 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 Who is doing it? Do it. Do it. All of it.
Do it now!
Come on. Do it now. And I will do the rest. Come on. Do it. Do it. Do it. Do it. Do it. Do it! Doing it. Do it. Do it.
NPN. This here now, this plus over here that you gave earlier from the battery turns into a negative flyback, and this becomes a positive, and then this positive flyback can flow through the load and go through the battery to hit the negative. Now, let me just say something here. As it goes through the battery, remember you're sending plus flyback here. Going through this load, and you're hitting plus flyback here on the negative side of the battery, okay? Which will not charge the battery, but it will use the battery as a path to get to negative in reverse polarity to what the battery is polarized to. So the battery won't really charge from this flyback, which is why we have the modified double pole, double throw setup. So what we got here, what do we got? Here's your flyback diodes. So plus will leave here, okay? It gets blocked here, so don't worry about that. Plus leaves here, goes through the PNP in the emitter, out the base, through this trigger winding, through the 1K resistor, then through the base of the NPN, out the emitter to negative, completing the path from plus to minus on both the NPN and the PNP. Okay, and that will trigger both of these transistors at the same time, closing them, giving you your double pole action on the minus and plus side of the battery, the source. So double pole, double throw means to switch both the plus and the minus side of your source. That's the goal here. So now that we established how we trigger this, we now close these two. And now we allow plus to channel through here. Through the drive winding, just like the standard dual feed circuit, through the load to the negative. And basically, you, by switching both these switches, you allow the drive coil to charge. And let me check the chat real quick if anybody's here. All right, if you guys want to join in and comment or discuss this, just put something in the chat. I'll check it every couple minutes. Where were we? So, yeah. So now the double pole, the two diodes are the two transistors are closed, allowing plus and minus to connect through the drive coil and through the load, priming the load or even lighting up the load. And then, of course, that happens for a pulse. At whatever frequency that this resistor puts the frequency at. So that resistor will create the frequency pulse. And then after the pulse is done, these two transistors open up. Okay. They're now open. And this coil, the drive coil, which you previously gave it a plus here, you put the plus here on the drive coil and the minus here previously, and now it's going to fly back in inverted polarity with a negative here and a plus here. And I decided to handle the flyback like so. I want the plus flyback to go through the load, so use the flyback to power the load. Whatever the load doesn't take will go through here back to the source, through this high voltage diode, hit the plus. That's the plus flyback going to the plus of the battery on the right polarity this time. And then the negative, of course, it cuts through the battery to meet the negative over here. So that's how the flyback channels through the battery and the load at the same time. Now, of course, I did not test this circuit, but in theory, I did just now. I went over how it should work. And I'm going to keep this circuit handy to test it, you know, in the future when I get around to it. Let me just put the plus here. And the minus here. There's your flyback polarity. And yeah, I'm pretty happy with this guy here. I'm pretty convinced it's worth replicating to see if it actually works. And there you can see how the plus and red flyback goes through the load back to the source. And you know, just like the standard Joule Thief was using the battery. Let me go back to that. You can see the standard Joule Thief here was taking the plus through here, through the drive, through the transistor to negative. Yeah. So, yeah. A little confusing, but so yeah, the plus is going through the drive, through the transistor. And then, you know, of course, that's plus there and that's minus there. And then it flies back with inverted polarity, minus and plus, like so. And then this plus, this is open now. And this plus will go through here and channel through the battery, even though this is the negative side of the battery. It'll cut through the battery just to get to this negative and light up the load with the flyback power. I'm assuming that's what's going on here. That's what it looks like to me. Yeah, but being that this is a plus flyback here, and that's the negative terminal of the battery there. That's positive. That means the polarity is not correct. That doesn't mean it's going to discharge the battery in any way. It's still energy. It's just it's just inverted. It's reverse polarity energy. So it won't actually charge the battery, but it can channel through the battery to get to the negative flyback and harness the flyback through the load. On a standard, you know, on a standard operation, the plus will go forward energy. The plus will just cut through the load like so to the negative. And if the battery is 1.5 volts and it's like a dead battery and it's more like half a volt, this is not going to light up because it's a 1.5 volt LED. So essentially this energy will not get through here, but it does get through here. It does trigger the transistor to flip and close, causing this transistor to close and charge this way without a load, to charge the coil with whatever little bit of energy is in this battery. And once it charges this coil with that tiny bit of energy, it then opens up the gate. You know, once it was closed, now it's open. And this little bit of charge in here flies back in inverted polarity with a higher voltage that can cut through here. So instead of half a volt, it's probably 20 volts with very low current. which is enough to cut through this load without burning the load because the current's so low. And it cuts through the battery again to get to its negative, to have a path. You need to go from plus to minus for this to work. So the battery is just like acting like a gateway. It's not really charging because, again, this is the negative side of the battery. That's the positive side of the battery. Okay. And what's hitting here is plus flyback here and negative flyback. So it's the wrong polarity. That's why I'm going with this guy. I think it's going to be more efficient in a way where it will actually hit the battery with the right polarity and it'll use the flyback alone as power for powering this. Sorry, I got that wrong here. Yeah, so the two transistors close and the power goes through the drive coil, through the load, standard forward energy. And then when you open up the transistors, the flyback happens in the circled plus and minus here, circled. That polarity. It happens on this coil and again goes through the load. But instead of going through the load and using these transistors to go through the load, because at this point they're open, so there's no path here for the flyback. These two guys are open, so there's no path here. So the flyback has to take this path to the battery, through the battery, to the negative of the flyback. And that path is should work because the battery will be having room for energy, to come back in for sure, because you just drained a little bit of energy in this drive coil. You just took a little energy to charge that drive coil out of the battery. And then that same energy is going to fly back into the battery. So that's the room that's in the battery, the energy you took out. So essentially there will be room in the battery to take the charge from the flyback, thereby allowing this load to light up. Yeah, so that's just a quick one there. I hope that was fun. I'll open up the chat if you guys want. Let me do that. Where is that? Put the link in there. Yeah, so quick little live stream on the dual field circuit, modified with a double pole, double throw, switching. One more time, I'll go over the NPN and the PNP. So the plus comes out of the battery, goes through the PNP, through the diode forward bias, out the base, through this trigger winding, through the 1K resistor, and then through the base of the NPN, out the emitter into the negative of the battery. Now that whole path right there will switch both of these guys to close. And when they close, you have charge on the drive coil in this path. And the drive coil charges up. Then they both open. And the drive coil polarity flips to the flyback polarity. The plus cuts through here, through the load. Cannot go this way because it's open. There's no path. So instead it goes this way. through the high voltage diode into the plus side of the source, through the source, out the high voltage diode, forward bias to the negative of the flyback. So in that way, positive meets negative of the flyback, creating a path. All right. Okay. I guess if nobody wants to chime in on this, I'll just leave this screen up here. Wonder why it's not. Oh, there it is. All right. All right, I'll clock out here, give another couple minutes. Maybe someone wants to chime in. The link's in the chat.
Yeah, I couldn't get any levitation or synchronicity. I am kind of I need to think a little bit because there's not a lot I can test with except for changing the configuration. The pole detector isn't picking up any pole, so that's not what we want. We want the configuration where we're actually picking up alternating poles. So interesting. It's spitting the sphere, but it's not synchronizing, and it's not picking up any poles with the pole detector. So I don't think this is the configuration we need for this. I don't know. It's not. It doesn't seem to be as strong as it needs to be to synchronize the sphere. I've had a lot better effect using the closed circuit where you connect the two channels. So I might have to switch back to the Nunez closed circuit method and test with that a little bit with the phase angle change. And we will have to reconvene on this because I don't know, I don't know how to proceed to get this sphere to levitate. There's not a lot of, documentation on how they did it online. So. So, Mike, can you hear me?
I'm sorry, my mic was muted. I was saying, yeah, you got to do a lot of experimenting.
Yeah, it's going to take some time to crack this one, but I did test those numbers, the frequencies, 45, and I couldn't get as high as 135. For some reason, the magnetic field just wasn't strong enough. But 45 and lower numbers that reduced to 9 did seem to have a stronger effect on the sphere, which is interesting. Like as soon as it hit 45, the sphere kind of spun a lot faster, and you can kind of audibly hear it pick up speed. So I thought that was
45
interesting.
Was a little better, you saying?
Yeah, the numbers that you gave me that reduced to 9, like you were saying, reduced numbers, frequencies that reduced back to 9. I tried that, and I tried 36, and 36 seemed to do the same thing. Like it spun a little bit, and then it hit that number, and then it just kind of like, if it was at the right angle, it would spin like crazy. So I don't know if it was just, the chaotic thrashing of the sphere and the containment, but it did seem like it had a little bit of a boost on those numbers. So we'll keep an eye on that.
Because those are resonant frequency numbers, and you get more efficiency out of those numbers. Plus, you want to try turning up your dial on your stereo.
Yeah, so I have to be careful with this one. Turning it up too much last time burnt the wires attached to my coil.
Oh.
Because you know, I was using the Arduino jumper cables, and you know, it's not a thick gauge, so that like immediately just it got real hot and it started smoking. So I'm like, yeah, there's a lot of power pumping through this stereo amp, but I just like power after a certain point. I don't think it's power that we're lacking now with the stereo amp. We have more than enough power. Right now, we just need to refine the technique and get the right frequencies.
You could at least turn it up to the midpoint.
Oh, I did. Yeah, that's what I did. I turned it up to the midpoint, and I might turn it up a little bit more. I have to find out what the spec is for these wires. The
then
gauge
there's
wires
also,
that I'm using.
you know what? The ohms of your coil, if they're too high, they won't let the power through.
Right. That's why we got to test different. I'm going to see if this other coil that I'm putting together has less resistance. So hopefully we can get a coil that matches the output of the recommended output, which is ideally we want 2 channels. So 4 ohms of resistance.
Yeah, if you can get a coil that's 4 ohms, it'll be and you know, it'll be in resonance with your stereo. It'll have the same,
Right.
You know, your stereo will be able to put the full amount of wattage through that coil, and being a lower resistance coil, it'll have a thicker gauge and it won't burn out.
What gauge do you recommend for that coil?
If you want to keep the same amount of turns, I recommend you don't keep the same amount of turns and you go with a thicker coil, because you said your coil burned out before, right?
The coil didn't burn out. The small jumper wires that I had attached to the output of the coil, they got hot and they melted.
So you need a thicker jumper wire, because yeah, your stereo has good power to it, and your coils are fine. They're thick enough, so you don't need to change the gauge. Just less turns to get a lower ohms.
Okay, so I'll just print. I'll just find another coil frame to print out with less turns.
Right. Yeah. Check this out. Where is it? What do they call it? Yeah, it's here. Check this out.
See if I can...
You see this? So you see the right side, the relay? That's the double pole, double throw relay. That's what I'm using to drive this Newman style motor, pulse motor. Newman did not use double pole, double throw. He used single pole throw, single throw. So he was switching one side of the source to power the coil, and the coil would have the same polarity each time. If you look at the top of the right diagram where it says plus and minus, green and red, see how it flips? It goes from plus to minus to plus and back and forth. The top 2 points, green and red, that's where the coil gets connected on this motor. So that's how that double pole relay is flipping the polarity on the coil with each pulse. So if you look at the magnet as it rotates, and let's say right now, let's say that the north is facing down, I'm going to produce a north field in the coil to push the north that's facing down away. And the south field would be on the top of the coil, and then the north field would be at the bottom of the coil. So the south field on the top of the coil would push the south field of the magnet also at the same time down. So both sides of that magnet are being pushed by the coil.
And that's a system that doesn't need to spin real fast, right? It doesn't have to have a fast RPM.
No, it just has to have torque. So let's say right now it's plus and minus, and the north is at the bottom of the coil, the south is at the top, and it's pushing the north side of the magnet facing down away, and it's pushing the south side of the magnet facing up away. It's repelling. And then the relay flips the polarity, and now the south is facing down, and the relay produces a south field at the bottom of the coil, pushing the south of the magnet away, and a north field at the top of the coil, pushing the north side of the magnet away. So during each 180 turn, there is a push. So on the Newman motor, he only pushes once every 360 degrees. This is pushing every 180 degrees. So that's the difference. More torque, no free rotation cycle, no free spins. There's no free spinning going on. So there would be more torque. And you could do that with a double pole relay. You can flip the polarity of the coil every 180 degrees and push the magnet every 180 degrees.
And what are you powering with this? Or are you charging a battery like this?
I'm using two 12-volt batteries in series to make 24 volts. And it's a 380 ohm coil, so I needed more voltage to get enough amps through the coil to push the magnet. And
what amp hours are that?
Yeah,
what capacity is the battery?
7 amp hours. But let me tell you something. That big ass magnet there, it would not spin with a single pole switch. If I were pushing that magnet once every 360 degrees,
yeah, you need a double phase.
It would not make it around once.
Yeah, you need to hit it twice.
So I push it every 180 degrees, and it spins. What I'm saying is, if I went with a single pole switch and I only pulsed it one polarity of the coil, north and south every time, that means it would get, because it's a north and south magnet. It's when it turns, you can't pulse the coil when it turns 180 degrees, because then you'll push the magnet the other direction. You have to pulse the coil every 360 degrees on the magnet turn.
What kind of runtime do you get off of that small little battery?
Oh, well, let's just say that the thing kept running, and what stopped it was I was using a 9-volt battery as the signal generator power.
So it would have kept going if it wasn't for the 9-volt.
Right, the 9-volt died, and it was a rechargeable 9-volt.
And the 9 volts, like you said, you said it's a trigger, or?
I was using that as a signal generator.
Okay.
To trigger.
Yeah, and that's not a part of the recycling of the energy that you're producing, huh? So
well, the 9-volt was powering the Arduino, and the Arduino was sending the signal to the.
That's interesting. Yeah, so this thing would have kept on going, and that's the only kind of point of failure.
Yeah, I believe it was
really
6 hours. It ran for 6 hours, then the 9-volt battery died, and I measured the voltage on the 2 series 7 amp hour 12 volters. They were in series to make 24 volts, and I started from like 26 volts, and by the time 6 hours passed, it was like 25 volts. Lost 1 volt, but it would have kept running, and
yeah, it kept running.
The reason awesome. Reason it ran so long, it only lost 1 volt in 6 hours, and it was pushing. What is it? Let me do something real quick here.
Well, I wanted to say real quick, like, I don't think a lot of people understand, like, regarding these energy recovery systems, like the Bedini SSG and all that, like, they'll run, like, I've had mine running for like 2 weeks straight off of the same 2 batteries, like, and that's doing work. You could attach a fan to it and actually have it cool you down in the summer. So, like,
here you go.
That's a lot of work that it's able to produce off of 2 small fucking batteries.
I just divided 26 divided by 380, which is volts divided by ohms. That's your Ohm's law to get my current. It's 0.068 milliamps. So 68 milliamps
16.
the
Yeah,
thing was,
that's nothing.
it was using 70 milliamps. Well, 70 milliamps is not a whole lot. But
Yeah, it's
still,
not a whole
70
lot.
milliamps was turning that magnet, you know?
Right. Well, regarding that, turning
It
that
didn't
thing,
have that
thing,
much
yeah.
torque.
That, for instance, that's about the range that my Lightning Thief runs. And my Lightning Thief runs very, very low current, very, very, like low power system, the Jewel Thief. So yeah, that's, I mean, for relative power output that you're getting, it's nothing.
Yeah, well, what is the watts on that? We'll find out right now if it's how much watts it is. So you know exactly what kind of power we're using. What is 0.0, let's say 0.70 milliamps. 0.07 times 26 is 1.8 watts. Let's say 2 watts. 2 watts is not a whole lot. It's a 7 amp hour battery times 2, so 14 amps. Amps times 14 times 25, let's say. 14 amps times 25 volts. 350 watts for an hour. Now I was using 2 watts an hour. Yeah. That means, well, you need to multiply 2 times something to get 350. 2 times 100 is 200. So this thing would have ran for 100 hours or more. 2 times.
Right, easy. If it's only consuming, yeah.
Well, so, wait a minute. Not 100. It would have, because once the battery drops below a certain voltage, let's say from 12 to like 10. So you got between 25 volts down, 4 volts total is 21
right,
volts.
Whatever.
So 4
volts. Voltage requirement for triggering it.
Well, once the battery hits 10 volts, it's not going to supply anymore. So you only have a 4 volt drop in those batteries before they stop pushing the thing. So 4 times volts times amps is 2 watts an hour. Okay. So I need to get watts. 4 volts times volts times amps times 70. It's 280. Oh, wait. 0.07. 4 times 0.07 is so I have 280 milliamps an hour. No, wait. Volts times amps is watts. 0.28 amps an hour. Watts. Sorry. 0.28 watts. So 0.3 watts. 3/10 of a watt an hour, and it was consuming 2 watts. So let's say 0.3 times 100 is 30 watts. 2 watts an hour. I have, what was it again? 2.3 watts. I got lost there, but yeah, there's a way to figure out how long it would run. Hey, it ran for 6 hours. I figured, and it dropped 1 volt. So if you just take another 3, multiply 6 times 3, I'd say it'd run about 18 hours. Maybe 20 hours before the battery would be out of gas. And the torque on that was maybe a quarter pound, because it was only consuming 2 watts, and the coil was a 380 ohm coil. So if you lower you consume more power, it'd be more torque. But Newman had like a lot more voltage than 24 volts. and like he had like hundreds, like 500 pushing through a coil that was probably in the couple thousand ohms.
What kind of magnet did you say that was made of?
Those are just standard ferrite magnets.
Ferrite magnet. Okay. Oh, I have the video clip if you want to show it real quick. It's just a short clip to show what I was trying to do, and we're close, but we didn't do it.
Everything becomes at its maximum acceleration. This experiment you're going to watch while I finish my talk, I want you to keep in mind when you're watching this magnet spinning around, there's no energy going into this coil. It's totally turned off. And I'll continue. Your blood cells are a torus. DNA is a torus. Magnetic fields, galaxies, all toruses. That's why a tornado is more powerful than an atom bomb. It's a one-way living systemic electrical machine, a self-sustaining jet. You might say a flying saucer.
So it's continuing to spin.
In a perfect
Look at the
3D,
distance.
4D and higher mathematical hologram.
And it's off.
It can be scaled up and down to infinity.
Yeah. So the thing is, I'm just noticing the sphere they're working with was closer to the sphere that I have. And I always thought like the mass has a lot to do with synchronizing it too. So I actually got better results with the bigger sphere. The smaller sphere didn't really do much. Maybe we can get it to levitate, but in terms of synchronizing like this, I think we're going to need the bigger sphere. But yeah, it's pretty cool.
Or sometimes
you said white, Mike?
You got someone in the chat there asking, what are the parts list?
We refer to it by Marco's name, which is the flux thruster, atom pulsar, electrical venturi, space-time implosion field generator coil. And with it, it's possible to create a localized space-time implosion, a controlled desktop black hole. That magnet's still spinning. There's no energy in the coil. This is
so, hello?
Yeah, the parts of Philip are a 380 ohm coil, 28 gauge, 5 pounds worth, and ferrite magnets. I think they were
what did you say the gauge of the wire was?
28.
28. Okay, so you got the thin wire.
But 5 pounds of it, 5,000.
But 5, okay. Oh, 5 pounds. Yeah, you got the big spool, but so it's very thin. So is that going to increase the resistance though? You said the higher
300,
the gauge?
380 ohms.
Yeah.
That's what it was, 5,000 feet. So when you have a higher resistance, you need to raise the voltage to get current through there.
Right.
Those magnets, I believe they were 4-inch by 1-inch cube ferrite magnets. And I was using a standard double pole, double throw relay to spin it.
Yeah, I'm going to have to try to make a couple of different size coils with different gauges.
Pin 7 and 8 on the right is the application of battery voltage. When you apply power there, it triggers the relay to flip. When the pins 7 and 8 are black, there's no power applied to it. And the relay is flipped to the right, which gives plus on the right and minus on the left. And when you apply power to 7 and 8, plus is on the left and minus is on the right. That's how you flip the polarity of the 380 ohm coil. And that will turn the magnet on that shaft. It will push it every 180 degrees. And I used an Arduino to trigger it and time it just right. I had to get the timing just right to get it to spin. So, you think you could just put it on any timing rate you want. It will spin.
No, you had to use the Arduino, right, to time it properly.
Right. So that's another thing you might want to try with the rodent coil you're doing there. Try slowing and speeding up see, that's the thing. You're using a speaker or amplifier. You can't really mess with the timing.
Yeah, there are limitations with the amp, but I
don't know. That video you just showed, I don't think they were using a speaker, were they?
No,
stereo.
He was using a custom board.
He was using
I'm not sure what he was using.
Yeah.
If you want to look at it, I don't know if you can actually decipher what it looked like a custom
Ben, get away from the
amplifier.
stereo amp. Listen. Nunez is a great guy, but you need to get a PWM and start that. That's the way to get past the learning curve, is use a PWM so you can turn that knob and you can mess with the timing, get it just right, and you'll see what I'm talking about.
Hold on, because I want to see.
A pulse width modulator will do your timing with the knob, make things a lot. You don't need to mess with an Arduino. It's just more involved and time consuming unless you want to. An Arduino is more accurate than the knob. You can do a lot more different things, but a standard PWM you can get for $10 and get started right away. And you can use the stereo amp if you want, and you can trigger the signal from the stereo amp with the PWM.
He's using some kind of custom board, so I'm not sure what he's using. He could be using a PWM. I have no idea.
He's using an Arduino or a signal generator to mess with the timing to get it just right. I'm telling you, the magnet and the coil have a timing relationship.
It would be a lot easier to tune it as well with an. If I can
what I'm saying is the magnet and the coil.
I do have an Arduino we can use.
Use the Arduino, or if that's taking too long to get it working, you can get a PWM with a knob on there. And
I had a PWM. I'm not sure if it's the right. Honestly, I think I blew it up. From what I remember, I think I blew up my PWM. I have to order another one.
Get another $10 one that has a knob.
But yeah, no, I remember experimenting with the PWM before. I couldn't get any magnet to spin with it though. That was my problem with the PWM. So I have to figure out how they did that.
You need to hook a 12-volt battery up to the PWM input, and on the output of the PWM goes to your drive coil. And now you can turn that knob to the right setting to get that magnet to spin the way you want it to spin. That's all I'm saying. With the stereo amp, you can't mess with the timing, and you're not going to get it the way you want it to spin. You're not going to get it to spin probably at all with the stereo amp without knowing the right tone to put through there. You know, you're going to have to mess through the tones like crazy to figure out.
The frequency seems to be key, and
it is, because the frequency is the timing. It's like
I have a feeling that we're going to need a bigger ball. We're going to need a bigger boat.
You're fine with what you got. It's the timing. You know, you unless you've gone through all the frequencies, you probably haven't. You know. And to do that,
well, that's the problem. Depending on the configuration that you have with the coil, because the resistance changes with the configuration. You know, if you're combining the coils or using them separate, you know, you have different frequency ranges and cutoffs. So we have to experiment with different configurations too.
Yeah. Plus, you want to probably lower the ohms on your coil closer to 2 ohms.
That's what I'm thinking. Maybe build a coil that's closer, like you said, to the requirement of the stereo amp, so I can utilize the output
power,
more.
all the power, right?
Yeah, all the power.
And consider this: what was it, Randy Powell, when he was using the PWM or the timer, he was pulsing battery power into that coil, which is the same thing as creating a tone from the stereo. When you change the frequency, it changes the tone. He was using straight battery power to the coil, and that means he was getting full juice from the battery to the coil.
Right. He had all the amps available instead of
the battery, right?
And that was another idea, Mike, that I had, is that's why I got the car audio stereo amp, the one that's able to be powered off of a 12-volt, you know, car battery, because I had a feeling like we might need, you know, like access to all that.
Because you burned one wire, you're a little scared to turn your amp all the way up. So when you're
the power supply, but no, I did get better results spinning the sphere with the car battery, you know, versus the power supply. So
because the car battery provided all the power, the power supply.
Yeah, exactly. That's what I'm thinking. So that makes sense.
And when you use the stereo, turn the knob all the way up, because you know you can't test without the power on full. You can't get your tuning.
Right. I just have to make sure I have thicker gauge wires attached to the coil. That's the only thing, because it gets
You
hot.
know, you turn it up all the way to get your tuning, get some action going, and then when you see movement, then you can turn it down until the part to where it stops moving, and then turn it back up a little bit. That's your sweet spot on the power. You don't want to have it on full all the way, but you want to have it on full just to get some movement going. And once you get the movement going, you turn it down a little bit to the point where it stops moving, then turn it back up. It moves again, and there you know you got your sweet spot. You see?
We also have high pass filters that we can play with too. I don't know, but yeah, it's gonna take a lot more time to figure this out.
What do you mean optics when you say optics?
Somebody said optics.
Elijah, the spin of the electrons must be coupled with the optics of the coil. That's the visual of the coil. Yeah, whatever that means, I don't know. The spin of the electron. That would be the frequency.
The closest we've gotten is with the other configuration, the Nunez closed circuit method with the giant sphere spinning. That spun really fast, and like I could hold it like about a foot outside the coil.
Were you using the stereo amp there? Or?
Yeah, we were using a stereo amp for that.
You remember
I
if
was
you had
using
it all
a
the way
MIDI
up
board
or?
for that, to be honest. And I think honestly, as long as it's an AB class amp, that you should be fine.
Did you have it juiced up all the way when it worked?
Yeah. Yeah.
There you go. Yeah, the coil, you got too much resistance on your coil, that's why. If you had a lower resistance coil, you wouldn't have to turn the amp all the way up.
And especially when you have to connect the two channels together with that one method, you just increase the resistance quite a bit.
Yeah, but if you lower the ohms on the coil with maybe thicker gauge or less turns,
right,
you don't have to turn your knob all the way up.
The only thing I'm concerned with though is when you connect the two channels together, you're kind of phase locking them, right? Whereas if you have two channels separate in the amp, they're kind of free to rotate, right? If that makes any sense.
What was that again?
So I'm not really sure which configuration to use, to be honest. But one of them, like the one where you're connecting the two channels together, it kind of phase locks them together, where they're kind of constricted. They move together in a certain way.
Yes, because the signal's going through both of them at the same time.
Right, exactly. But there's another configuration where you can separate them, and they're completely independent fields.
That might be a better option because you can then mess with the timing more.
With that, yeah, I think
by
might
changing one tone through one channel and another tone from the other channel would mess, offset the timing, maybe get you a better effect, a more efficient effect.
Yeah, no, that's the method we're testing right now.
It's all experimentation, really,
Yeah, I think I'm gonna need a proper tone generator, honestly, because we need to, like you said, input two frequencies, but one of them I need to sweep, and I can't do that with the app. The app that I'm using doesn't let me sweep with dual mode, so.
I know the B field is the magnetic, even in the central zero B field. Zero magnetic field, A vector. I forget what the A is. I can't remember these. E field is the electric field. B field is the magnetic field. And the A vector angle, was that the angle vector allows for the magnetic torsion in the sphere due to phase shift, the angle. Yeah, so your magnet has definitely certain angles of magnetic field that it puts out, So what he says there makes a little bit of sense. So yeah, the electrons in the sphere phase shift from the magnetic field. Right, so if you put them in each coil separate and you're able to send a different tone through each one, you can effectively manipulate the angle to match the angle of the magnetic field coming off the sphere. You see, because you have one tone going through one coil at one angle, another tone going through another coil at a different angle, when the two angles combine, or you move them around, eventually
and if you think about it, that's exactly how acoustic levitation works too, in the sense that if you want to move something in 3 dimensions with acoustic levitation, you would have a base frequency and then you would have another frequency that's phase shifted. And that, like that shift moves on one dimension or another.
Yeah, if anybody wants to join in and contribute to this discussion, he's got a toroidal bifilar rodent coil. He's trying to get the magnetic levitation on the sphere magnet.
Yeah, we're trying to get it to levitate in the center, or get the sphere to synchronize too. But we haven't had much luck with either of them.
Thick and creamy cappuccino. I like that name. I don't even drink coffee, but that does look good. I mean, I've had coffee here and there, and it's good stuff, let me tell you, but I don't drink it regular.
What if to spin the magnet is to multiple frequencies? Yeah, we were just talking about that. Dual frequencies, having a base frequency to stabilize it, and then a sweeping frequency to kind of spin up the sphere.
Schwarzer device. I don't even know what that is. Let's look that up.
Yeah, I'm not sure who Ben Schwartz is. So we're actually running them with AC right now out of the stereo amp. So we basically have them hooked up to a stereo amplifier.
Oh yeah, the amp is AC, so.
Yeah, the Lightning Thief is DC. That's the system that we run off of DC. That's pretty fucking efficient. It has its limitations though. The coils themselves seem to react really well to pulsed systems in general, like anything with pulsed DC or in AC as well. So they just react really well to.
You got a link, thick and creamy cappuccino, to that Ben Schwartz device? From one at a time, you need phase conjugate waveform. Yeah. What does conjugate mean? I never really knew. I'm being honest here.
Let's look it up.
It means, I think it's something to do with constructive interference or something.
To join together a pair. Okay. Conjoin, conjugate.
What, 2 frequencies?
But in mathematics, it's to change the sign between 2 terms in a binomial. For example, the conjugate of x plus y is x minus y. Oh, so it's like the polar opposite function. In chemistry, to link 2 or more distinct chemical substances together.
Yeah, it's conjoin is what it means.
Yeah. I didn't know that either. I had to look it up.
So to join 2 waves in a constructive interference way, where they, don't you don't want a destructive interference going on, because you lose power like that. Amperage.
Now that I'm thinking about it, depending on the mass of the magnet, the power factor is going to be important to precisely tune too, if you're going to levitate it, because it can't be too powerful and it can't be too weak. It has to be just right. So there has to be maybe along with sweeping the frequency, we have to adjust the volume level dynamically as well.
Yeah. Your magnet has a certain range of EMF that it puts out, where it's maximum. Of course, it goes a little further, but it's weaker. And you want your coil amperage to produce the same range, not more and not less, because then if you put more EMF out your coil, you're wasting the power.
Right.
It's like putting two like magnetic poles onto each other to where you get repulsion, right? And toroidal moment going out the orthogonal plane. You know, I looked up orthogonal the other day and I totally forgot what it meant.
It just means perpendicular, like you're at a right
Like
angle.
Parallel? Oh, at a right
No.
angle.
Yeah, at a right angle. So say
Vertical
you have
and
a flat
horizontal.
plane, something coming down.
Vertical, horizontal.
Yeah, exactly, like a T.
Of the force.
That's how I imagine it. But yeah, I recently had to look up that term as well. So I mean, I'm a kind of person who, if I see a word that I don't recognize, I look it up immediately because it bugs me.
Yes, he's trying to levitate the sphere magnet inside the center of a rodent coil.
I think the levitation is going to be harder to do than the synchronicity, honestly. I might try the.
When you say synchronicity in timing, but for what? For the spin?
Yeah, just for the spin. So it spins outside of the coil quite a bit, and we know that it's synchronized because if we'll turn off the system and the sphere will keep spinning for a little bit because, you know, the coil acts as a capacitor. Right. So it should bleed off some of that energy even with the system off. And when you turn off the system, you should see a boost initially because, you know, when you turn off the system, you get kind of like that electron jolt.
Yeah, I mean, I don't really focus too much on levitating experiments. My thing is, you know, either free rotation or harnessing the flyback to do, you know, get over unity effects, you know.
Yeah, these are
Solid
energy
state.
recovering systems that you're working with primarily.
Right. I mean, I'm trying to, you know, utilize, if you look at the toroidal thing, I already went over that. Let me show it again. Let me see here. Where is it? All right, so the toroidal one, share screen.
И это все лишь миг судьбы. Я недоволен, все так серьезно.
And it will send. I went over this earlier. I had to use like so. Double pole. Switching, 2 coil setup. And how does this one work? Cool. It works by double pole switching. So this is the, where is that? This is the toroidal double pole single source pulse, solid state pulse generator, or you can put a shaft with a magnet in the center of the toroid to make it a pulse motor if you want. So I go over how this works here. Basically, you double pole switch the bottom coil, close it, then open it, and then you close the top coil and then open it. And you keep repeating that. And when the bottom coil is closed and energized, the EMF is transmitted to the top coil. And at that time, the top coil is inactive. It's not energized. So it can act like a stator. And therefore, the bottom coil is EMF transmitting to the top coil and funneling the EMF back to the source battery with those diodes. I go over exactly how that's happening. So I'll let it play now. I'm going to go over this. So you have your plus on the battery here and your minus. What happens is, let's start with the top coil. This switch up here will close together with this switch. So 2 switches, double pole. Okay, both those switches will close, enabling the plus from the battery to go through to charge up the coil, like so. And the coil gets charged to negative. And then what happens here is you have your north on this side and your south on this side. All right, so we see how the coil got charged when the 2 switches closed. And because your plus is here and your minus is here, and this is a counterclockwise wound coil, that means the north is on this side. If it were clockwise, the north would be on the other side. But it's not clockwise, it's counterclockwise. So the north is on this side. I had to use, both of these coils are counterclockwise. They had to be counterclockwise for this to work. Excuse me. There was no way to do it with clockwise wound coils. And to work in what way? Well, the goal was to, when the top coil is charged, the goal was to send the charge through the core to the other coil. Of course, while it's doing that, you know, whatever rotor you have in the center here with a magnet can spin. But when the top coil is charged with the north on the right and the south on the left, what was that noise? Your browser has lost connection to your camera. Okay, whatever. Screw the camera. So the north is on the right, south is on the left. Now the bottom coil is inactive. It's not being switched when the top coil is active. So the bottom coil can be a stator coil or a pickup coil, pick up the charge. And it's going to pick up the charge from the north on the right. It's going to send this north this way through the coil, I guess that way. And that would be the rotation of the field. And so that basically means the north. Let me just add that the rotation is always clockwise on that toroid. So whatever shaft of the magnet you have in the center will turn the same way, and you won't have any stopping effect going on. There's no reversing the rotation here. It's always clockwise because of the way the coils are counterclockwise wound. You see how they're labeled north and south, and that tells you the turns, the turn of the field. From the top coil lands down there, and the south is over here. And because the north is on the bottom coil on the right side, the bottom coil receives that north and channels it this way into the source battery's positive, out the negative to the south of the coil, same coil. You see that? Okay, so that's how the top coil can induce the bottom coil and send that induction back to the source battery. So whatever the rotor doesn't use to spin in the center, the bottom coil being inactive during that pulse on the top coil can be a pickup coil for whatever the rotor doesn't use. And it will send that leftover power back to the battery. Okay, so that's the top coil cycle. All right, now the top coil is no longer induced and it's opening up the circuit. And these two switches now are open. Okay. And then the bottom coil gets switched. So these two bottom switches close. And when they close, the plus energy comes out the battery right here through the coil, out the other end of the coil to negative of the battery, thereby charging the bottom coil. And you see plus went in the coil on the left side and counterclockwise. So that makes the north where it is here on the left and the south on the right. So what happens now is the north field from the bottom coil being induced will channel up through the core in this direction and out this side to meet the south, thereby putting a north on this side of the coil and a south on this side of the coil. The top coil now. The top coil is inactive, whereas before it was active. Now it's inactive, but the bottom coil is active, and its induction is channeling to the top coil. And because on the left side of the top coil you have a north, that enables the stator coil on the top to now, it's a stator coil now. And switches are open, but there's still a channel here for the power to come out the north of the north field of that coil on the top coil can come out through that diode and hit the positive of the battery, go through the positive, out the negative, and all the way over to here through this diode on the right side and meet the south side of the coil, thereby charging the battery. So basically whatever energy came out the battery and went into the bottom coil goes into the top coil back into the battery. But in that process of going from the bottom coil to the top, if you have a shaft here with a magnet in the center of this core, you know, it will spin. It will spin. And as it spins, so will the power go from the bottom coil to the top coil and back into the battery. I think that's pretty efficient. So that's basically the concept of this whole system. The toroidal now, you know, it's a bifilar, but it doesn't operate like your standard bifilar. You don't have, it's not a bifilar because the coils are not wound around each other. You have one coil wound on one side of the toroid and the other coil wound on the other side of the toroid. They're both counterclockwise wound and they're both double pole switched. And you have your diodes in the position you see here. To verify that when this bottom coil is being switched and the plus comes out here through the coil back to negative, This direction here is blocked by the diode. Yeah. But that diode serves a function of sending power back to the battery in a different part of the cycle. Yeah. So yeah, we went over that. May have to rewind this and watch it again. But I just want. So let me see here. Where is that? The only thing I'm not sure of is when the bottom coil is closed and energized, sending the north on the left to the top coil on the left, because that's a counterclockwise wound coil. I guess the north would stay on the left, right? Or would it show up on the right? Parallel to the field. Yeah, but I think it would stay on the left, north on the left, top and bottom. And being the north is the greater potential, it would act like the positive, hitting that counterclockwise coil on the left, top coil, and the south being the lesser potential would be like the negative, hitting the right side of the top coil. So positive from left to right on a counterclockwise would still put a north field on the left on a counterclockwise coil. I hope that was interesting. Yeah, I have to replicate this. I haven't got a lab set up or nothing. And that's a two-phase motor wheel on a scooters. The magnet is usually on the outside coil or stator on the inside. Yeah, there's so many ways to do these motors. It's incredible. I wonder why this one isn't playing. Anybody want to present? Just your links in the chat.
I'm about to close it up in a minute. We got some, I don't know, better effects with the closed circuit. I was testing different ways of configuring everything, but yep, nothing yet. Nothing concrete.
All right. In due time, Ben.
Yeah, I'm going to continue to test. We might have to get like a proper function generator, you know, something that I can like program and mess with a little bit more freely.
Do you have a PWM, Ben?
I did. I think I blew it up. I have to check. If I blew it up, I threw it away. But if I have it, it's probably workable or still working. So I just can't remember if that was the component I blew up or something else. But I might just order another one next week.
You might want to just do it with the PWM and straight to the battery and the coil. And, you know, slowly turn that knob. You have to turn it slowly because if you turn it too fast, you'll jump right past the sweet spot. But then you'll, you know, once you find the frequency with the PWM, you can measure it with an oscilloscope and use you know, any other function generator at the same frequency. Yeah.
shoebox cash to the foreign cars. I still feel that block when I grip this wheel. Every laugh, every loss, that's the part that's real. So now we talking fast stacks, rubber bands tight, came up from
So yeah, I think we're gonna close it up soon.
used to pray for $1 for the bus ride home. Now the roof peeled back, city in my real home. Yeah, we got fast stacks, but the love is deep. If my people ain't good, I can't really sleep. I remember every night, every cold street.
All right, Ben. So what do you want to do? Close out the show, or?
Yeah, I'm gonna end it on my end. I got a couple things to close up here on the lab, but I'm kind of tired, so I'm gonna close it up for tonight.
Okay. All right. Sounds good.
All right, Mike. It was awesome spending time with you this evening. I hope to do the same next Sunday if you're on.
Yeah. Sorry about today. I got up a little late. I had planned on doing some stuff on the house, working on the house and stuff, and had to get that done. But I appreciate you joining, Ben. And yeah, keep working on that. You'll get there, man. You know, it may take a while, but once you get there, you'll be like, it was worth the effort.
Yeah, that's exactly right. I appreciate it, Mike. I'll talk to you later, buddy.
All right, man. Have a good evening.
You too.
All right, man.
Choisir mes pas timides, sentir mon cœur courir, battre un peu de travers, être un vrai garçon juste une fois sur la terre. La poussière dort sur la scène.
Do it! Do it! Do it. Do it. Do it. Do it. Do it! Who is doing it? Do it. Do it. All of it. Do it. Come on! Do it now!
Mes questions sous ma peinture un peu.
Now we're to the rest.
J'invente des souvenirs râpés, des colères et des dimanches à courir. Je voudrais marcher sans